Now we can look at the marginals. The probability who purchased a plasma, 26%. The probability who didn't, 74%. The probability who purchased a DVR slightly over 35%, 108 out of 300. Or the probability who did not purchase a DVR, 192 out of 300. But if you want to be more complex, you could say who did not purchase a plasma but did purchase a DVR. So probability of no plasma and DVR. And again, that's 70 out of 300. Okay? Lots of things we can do on this contingency table. Okay, I'm looking now at the two words mutually exclusive and collectively exhaustive. Okay, these can be a little bit intimidating, but don't worry. Mutually exclusive and collectively exhaustive. Pretty simple concepts. If you think about mutually exclusive, they cannot both happen at the same time. You cannot both be a boy and a girl. Okay? They're mutually exclusive. If you are a girl, you are not a boy. And if you are a boy, you are not a girl. So these are mutually exclusive. Other ideas. Wealthy and poor. You cannot be both wealthy and poor. You cannot be both wet and dry. They're mutually exclusive. If you are wet, you are wet. If you are dry, you are dry. Collectively exhaustive means one must happen. Okay? So collectively exhaustive, if I were going to read directly out of your book, is that one of the events must occur. Okay, so I have here Democrat, Republican, or neither. Okay, this has to be the case. One of these has to be the case. You have to be either a Democrat, a Republican, or neither. There can be no scenario here that does not fit you. They're collectively exhaustive. Something, you have to fit in one of these categories. Okay? You know, you get into a lot of political debates when you say boy and girl are collectively exhaustive, because there are many civil liberties who are arguing for a transgender to be added on census, say for instance the 2010 census that will come out. Male or female, some would argue that those are not collectively exhaustive. Okay, so another category for transgender is being kicked around to be used. So these are different things what we have to think about. But you cannot be both a boy and a girl. These are mutually exclusive. One would argue that you cannot be both a Democrat and a Republican. Some would argue that they were mutually exclusive. So I know that the lines are blurred a little bit here. But for instance, you cannot be both a University of Texas fan and a Texas A&M fan. They're mutually exclusive. I think you have a hook 'em horns or a break 'em off expression in Texas. So these are mutually exclusive. Now, the general addition rule, which is referenced on page 154, I keep losing my... The general addition rule, I think, is hard to grasp without a picture. And I think many things in statistics are done better with pictures. So I'm going to give it to you in a picture. I told you already, and if you wanted a head and a 3, we multiplied. We multiplied the two simple probabilities. We multiplied a head and a 3. The probability for a head was 1/2. We multiplied with the probability of getting a 3 on a dice, which was 1/6, and we got 1/12. Okay? The general addition rule is not for and, it's for or. Yes? It's for or. Now, it gets lost when you see in the very first sentence. This rule considers the reference of A or B or both How can you determine that the household planned to purchase or actually purchase a big screen television? I don't know. It's confusing. But it's a very fundamental property that you need to know. So, or, that's demonstrated by a picture. This picture is called a Venn diagram, named after a man with the last name of Venn. Okay, a Venn diagram. And this is, with the new crisis that's going on in the economic conditions of today, the probability that, let me back up, okay? I'll start with one circle. Now, each one of these circles is an event. Okay? This event is the probability that you will lose your job. Okay? That you will lose your job. Yes? This we will call probability event A. Now, this circle, which I will draw in red, the red circle, is the probability that you will that your car will break down. Okay, and they each have a certain probability attached to them. Yes, they do. Now, the part in the middle, which I will represent with this curly Q, is the probability that you will lose your job and your car will break down. Okay? And that you will lose your job and your car will break down. Okay? So, this is what we have working. Now, each one, if I were going to be totally perfect, this would have a box around it. The box is my sample space. So, the box is my sample space. This is, the black circle is A, probability of A. Let me put this piece of A here. In the red, I'm going to do piece of B. Okay? The center, down here, probability a car will break down, we call that piece of A intersect B, written like this, with an upside down U. Probability of A intersect B, here. So, the probability that you lose your job, this probability of A, I'm going to say in today's economic conditions would be 10%, because there's 10% unemployment right now. So the probability that you lose your job, or I'll put it here, the piece of A equals 10%. Okay, 10% chance. Probability your car will break down, I'm going to say is 20% fail rate on automobiles. So probability of B equals 20%. Okay? 20%. Now, I say the probability that that you lose your job and your car breaks down, I'm going to put that at 2%. Okay? So 2% here. Now, I'm going to go ahead and fill that in. The whole black circle is 10. But remember, there's 2% chance that they both will happen. Okay? So I'm going to, on this side, I'm going to put 8. Yes? 8. 8% chance that you only lose your job. There's a 2% chance that you lose your job and your car breaks down. And there's a 20% chance your car breaks down. Don't forget about that 2% overlap. So that leaves 18% here. Okay? Now, this whole thing is our sample space, which represents the whole total, the sum total, which is 100. Now, 100 minus 28, which is 72. Okay? 72% chance that you don't lose your job and your car does not break down. Okay? 72% chance. Now, if I were going to ask you, what's the probability that you lose your job or your car breaks down? Now, you might be tempted to tell me probability you lose your job 10%, probability car breaks down 30%. You might be tempted to tell me that it's just 30%, a 30% chance.